somebody posted on the forum that I had told you to add the mouse listener to your JFrame. And he had indicated that if you make the mouse listener attached to the panel instead of the JFrame, then the XY position you get is actually the tip of the mouse rather than off by. In fact, let me bring open my little turtle program. Be more specific. Here I am in my shell. I'm going to build my little turtle program. And here we have the turtle attack game that we all know and love. Notice when I click, look at where my mouse is and look at where the turtle went. Now draw a bounding box around that turtle and see what you see. Notice that the difference between the top left corner of that bounding box and where my mouse is approximately off by the width of this edge right here and the width of that border up at the top. You see that? Let me try that again. So I'll click here, the turtle goes. See, he's quite a bit below where my mouse actually is. The thing that's causing that is we attached our mouse listener to the JFrame, or rather the game class, which inherits from JFrame. And so when it returns an XY position of the mouse, it's relative to right here. But when you draw the turtle, it's relative to right there. And therefore, that distance is probably how far off your mouse is, and I bet you that's causing a lot of these weird issues. Now, let's talk about the solution. Okay, I'm opening my game class. In fact, let's open the controller class. And let's first talk about the hacky solution. Somewhere I'm receiving clicks, right? Where's that? Mouse pressed. Okay? Suppose when I get a click, I actually say plus 30. There, I just hacked the thing, and now I bet you it's going to be pretty darn close. Let's see if that works, and then I'll show you a better solution. So here's my turtle. I click, and wrong direction. By which I meant minus 30. And I bet you this one needs a minus 2 on there or something like that. And we could sit there and calibrate it to our heart's content, right? Depending on how much we cared, we could get it exactly right. Here we go. Almost right. We could tune it a little bit more. Essentially, I guessed that border that says turtle attack at the top of the window was 30 pixels high. Apparently, it's about 26 pixels high or something like that. And we could sit there and adjust it. So that'll fix a lot of problems right there. Why is that an awful solution? Yeah.
It's different on mine.
Yeah, because I'm on Linux and you're on Mac or Windows or whatever, and your operating system's going to use a different size border there, and you kind of want your program to work on any platform, right? So while, yes, you should be able to hack stuff because that's an important skill, it would be better to Google around for the right API that queries the exact height of that border and insert it right here. Or alternative solution is this. Let's go to the game class. See how I added this .mouse listener right here? Instead, if I say view.add mouse listener, now build Java game. Here I am. Now I click, and whoa, it's way wrong. Is that because I forgot to remove my hack? Maybe I forgot to save and rebuild it. Okay, now I click. It must have been something like that. See how that's fixed? Okay, yes.
Should we do the same for the key listener?
That's an interesting question. The reason I actually put the key listener on the JFrame is because when I put it on the panel, it didn't seem to respond to my keys. That might be a Linux only thing. I don't know. So I guess the answer is give it a shot, see how it works out. And that's going to be the answer to a lot of questions here. If it works, I'm happy. If it doesn't work, I'm not happy. And so kind of your job is to make it work. Let's try it right now and see if it works. So I'm going to put the key listener on the J frame. And I build, I run. Still responds to mouse clicks. Now I'll press some keys. It's no longer responding to my keys. I'm guessing that's because my J frame is not selected. So maybe, or excuse me, I think the frame is selected, but the panel is not. And I'm sure we could play games. We could write some code to go tell the panel to tell the program to select the panel instead of the frame. We could make one of them selectable and the other one not selectable. And at some point, I'm getting confused as to what this even means, and I don't know. So I'm going to bail out here and say the answer is to hack it till it works on the keys. But I like this. Make the mouse attached to the view rather than the panel because that seems to give you more accurate coordinates. Fair enough? Okay. Great. Here's an issue I'm seeing a lot of people doing. In your build.bash script that you've submitted, a lot of you have javac game.java, and you don't mention the view or the controller or the model. In fact, I don't even mention the model. Okay, I'm setting a bad example for you. There we go. Now, here's the way that works. What Java does when you build, if you say javac game.java, it's going to build game.java and all of the other files that it needs to build. Which ones does it need to build? Well, all the ones that don't have an existing .class file, because those are the ones it compiles. Now, if I make a change in controller.java, but there's already a controller.class file there because I had previously built it, and then I do javac game.java, it's going to say, oh, controller class is already built, not build it, and then execute my game linked against an old version of controller. Does that make sense? You see why that's bad? Because then I get all frustrated where I made code changes and didn't affect the code, the actual code, and I pull out my hair trying to wonder why the computer isn't doing what I said. Well, basically the solution is, in your build script, make sure you're actually building everything so that when you build, you're not going to hit these really obnoxious issues of thinking you built and having not rebuilt and not understanding why it's not doing what you say. Computers do what you say. If they're not doing what you say, you're not saying what you think you're saying. Just general rule. You might think you're saying it really, really clearly, but there's something where the computer's right, some technicality, and you got to figure out why the computer's right. And when you know, then you fix the way you're saying it, then the computer does what you say. That's kind of how computers work. Okay, any questions on that? Fabulous. Another point down. Next thing I want to talk about is passing parameters. I use the word pass here. And some of you are a little confused about that, so let's talk about it. Public static void main string args static void foo. Okay. Really simple structure here. This program starts out in main. Main calls foo. Foo executes and does absolutely nothing. Foo returns. Main is done. Main returns. The program is done. What does this program do? Absolutely nothing. Well, by absolutely nothing, I mean it divides up the memory of your computer into the heap and the stack. You remember that? And then onto the stack, it's already got a whole bunch of frames from whatever was there before. And then on top of that, it's going to put a return position for main. This is where it's going to return from after it's done with main. And then on top of that, it's going to push a return position on for foo, right? So what's actually happening is when it calls into foo, the instruction pointer sticks its finger right there on foo. So right here kind of has a finger there and says, okay, remember, this is where I'm at. And then it comes up here. Think of it like you're baking a cake. And as you're baking the cake, it says, okay, now go make the frosting. What do? Well, you don't want to lose your spot in where you are baking the cake, but you have to turn to page 29 where there's the recipe for making frosting. And you follow the frosting recipe until it's all made, and then you come back and say, I don't know where I was, and you start over and you make a new cake, right? No, you remember exactly where you were, and you resume right at the step that said, put on the frosting. Okay, so foo is the frosting, main is the cake. Dumb analogy. But the point is, the reason it uses this stack is it puts on the stack a pointer to where it's at. That pointer basically says, I'm right here. Pretend there's 50 lines of code, so that's meaningful. Obviously, you're right there. That's the only dumb line in the whole program. But when it calls into foo, it's going to do everything in foo, and as soon as it returns, how does it return? Well, this closing squiggly brace you can think of as the return command. And what that means is, go to the stack, and whatever's on that stack, this foo here is a symbolic representation of where I used to be down here in main. And so it changes the instruction pointer down to where it was and continues executing. You see how that makes sense, and that's how a computer can work, and that's how execution works? So what this program really does is, in memory, it adds something to the stack and then pops it back off and then returns. It will do nothing for the user. It will display nothing to you, but something did happen internally. Something got pushed on the stack and then popped off of the stack. And yes, that's worthless, and yes, this is a stupid program, but hopefully you learned something, right? Get what a stack does in a computer program? Okay. Now let's suppose we add a parameter to it. Let's say int x. Now down here, I'm going to make another variable. I'm going to call it int I. What is the value of I? In Java, it's 0 because everything's initialized to 0. But now it's explicitly initialized to 0. And just to be interesting, let's set it to 3. Okay, what happens if I compile this code? It says, there are no foos that accept no parameters. And then I rip my hair out trying to figure out what the heck that means, because it speaks in weird cryptic language. And eventually it occurs to me, foo requires 1 parameter, and I'm calling it with 0 parameters. That's a compiler error. Learning to understand those compiler errors is very important. So let me give you a piece of advice. Whenever something goes wrong and you find the solution, don't get excited and move on. Slow down. Go back and see what that compiler error was that told you to find that solution that you have already found. And then think about it and let it sink into your mind and realize that those words that compiler said to you mean that solution that you already know. Does that make sense? Because you need to learn to talk to the compiler, by which I mean the compiler will talk only to you. And when you get to the point where the compiler throws an error at you and you just say, oh, I know what you're saying, and you go there and you fix it, then coding becomes faster, and faster is more fun, and yay, the world's getting better. Okay, so please read your compiler error messages, read them closely, look at the line numbers, look at the variables, look at the compiler messages. People that don't look at them struggle with programming for a darn long time. Okay, I'm going to have to pass in I here. Now, what's the value of x right here? If I do a system.out.println x, what is it going to print? 3. Therefore, the value of x is clearly 3. But wait a minute, I thought I was 3. Which one is 3? They're both 3. What if I say here x plus plus? And just for giggles and wiggles, what if I print, what will happen if I compile this? Compiler error doesn't know what x is because x is only in the scope from here to there. If I print it right here, will x be 3 or will x be 4? The answer is test it. The answer to everything is test it, by the way. Sum class.java. Oh yeah, and save it as a Java file so you get syntax highlighting. Java C sum class.java. Error. What? Oh. My own example error burned me. Okay. build again. There we go. Java sum class. I run it for 3. Look at the code again to figure out what we did. We called foo, went up to here, printed 4, returned, came down here, printed 3, and you now say, wait a minute, I incremented x. What is going on, right? Yeah, I passed by value, not by reference. And I want you to understand that and get what it means, because getting that is really the core of opening the hood and understanding how Java really works inside.